Good afternoon, everybody. Today, let's do something fun. Let's use ChatGPT to solve one of the IOI 2022 problems. Let's pick one that is not difficult. Last week, we talked about island. Maybe it's a little bit too difficult because it uses strongly connected components. Let's do the insects problem. So if you remember the insect problem, there are an insect that you can put into a machine that you can press a button that will tell you for the most frequent insect, type of insect in that machine, what is the count. And then you can put the insect in the machine and you take an insect out of the machine. The question is to find for the rest insect, for those n insects, what is the number of that insect? Last time we talked about we can do this with binary search, if you remember. And do that with a binary search, which is the W type of insect. You know that by keep the number of insects is 1. And then for every time you put the insect in, you set a number, right? Which is the target you're going to binary search. You try and any insect goes in there. If it's more than that number, you pop it out. And then once you finish that operation, you see whether everything is that number. If everything is that number, that means the minimum is above that. If the whole thing is not W times H, then you know there's something empty, so something below. So do binary search, you find it. And you can find that by 3n, and you can find it by n log n. And then you can optimize that by don't flush everything out. Only, everything you filled, you keep it, right? So you get to 3n, and you can slightly reduce it by less than 3n, right? So basically it's a binary search. So let's see how can we do this. So I started a new ChatGPT, and I'm going to use Notable so that it can write the Python code for you. So I'm going to use ChatGPT 4 with Notable, okay? So I'm going to set this as my IOI 2022 project, right? So I'm going to set that my Notable. So it's going to write the Python code for me. I did. Okay. Anything I can do, and say, consider yourself as a computational computer science programmer. Write code to solve the following problem. Okay. So let me get the problem, which is here. Okay, the problem. Okay. Okay. Get it going. It actually says the problem can be solved using binary search. Get the minimum number we can track, and then just default the problems. So minimum cardinalities. So this algorithm uses binary search to minimize the number of calls. So it's actually roughly correct. So then it says, set it to the middle. The range in middle, it moves the first mid-range of insect into the machine. Crash continuity, max continuity. Square to middle, there are at least this much. That actually is not correct. Does not give you the answer, right? Move. So it gives the it gives a maximum, right? It does not give me the minimum. And this one is such a minimum number of calls that you keep track frequently. That absolutely is not correct. So let's say algorithm is not correct. So for prompt engineering, there's something which about prompt training. Okay, so the way what it does is you can actually give them examples to tell the model. You give example to the model, so it actually will improve. Right. So if you look at the code, okay. If you look at the code that is provided at this moment, it's doesn't give me the code yet. So let's say your algorithm is not correct. When let's say if I have two type, let me give you an example, right? So if I have two type, if you run the examples provided in the problem, it actually if you actually the answer from the code is not correct. So okay, so for each insect, move it in insect machine and press a button and keep track the maximum and binary search fund. Then how to use binary search it. So it does give the binary search, right? Find the maximum of each insect type for and if not insect inside my but you don't know the inside. For this problem, we do not know the inside for each. So for each mid value, okay. So for range in the middle, cardinal express bottom without. That's still not right. First write the code in this project and run the bench exam provided. Maybe I have to tell him to write it in the notable project. Just writing it. It will write the code and ask it run. It will see it doesn't give you the right result, and then it's supposed to optimize itself. Remember in the beginning, right? I set the program, set this my default project, right? So I'm supposed to run, supposed to write the code for it. Sometimes that's okay. Sometimes it will correct itself. But if you look at the code, this is a code it's written, right? And it will run itself. And then you find, oh, I made some mistakes. It will correct itself and rewrite the code. So if you look at the algorithm, every time it actually does not really understand. If you look at the interpretation, it really does not understand. We want to find the count of the least popular insect. But it still seems it cannot grasp that idea. You want the count of the least popular. It keeps trying to find the most popular one. It does use a binary search, but it just cannot grasp that language, that concept. And then it's taking a long time to correct it. So let's look at the code what they provided. Okay, so as I said, it was wrong, right? So let's give them an example. So consider a scenario that shows, let's put that, consider that scenario. Okay. So let's train it. I mean, still writing. Consider scenario of that. The procedure should be done one. Procedure should return one. Is from your things. This scenario. That does understand. So make adjustment. Right. So now this is basically an improvement training, right? Sometimes called fine tuning. I give them, this is what we call one shot, right? One shot optimization, because you give them one example. Before that, it was called zero shot because I did not give them an example. So now I give them one example, it's called one shot. Algorithm they realize can be more sophisticated. Moving setting that impairs and possible. Made a mistake on the code. Right, so made a mistake on the code and try to rewrite the code again. Then you're going to rewrite another code. But still have not find the algorithm where I showed here, which is you fill in until the binary number you're trying to find, and then pop out everything beyond that and see whether this amount of insect inside is equal to W times H. Right? That's the algorithm we want him to do. So still cannot find it. So still trying to make the correct code at this moment. Actually could regen, but I will let it run a little bit more. Because for the paid version, I only have, I think, I can only make 25 questions every 3 or 4 hours. I'm on the paid version at this moment. Okay, let me just reject. So it actually says, sorry, I cannot do it. So let's reject one more time. This is where the shortfall of ChatGPT comes. In this case, I would say it is as problem. You see two problems. One is the ChatGPT itself. The other is how the problem statement was written. Right? Frankly, the problem statement was not written in a way that is very easy to understand. It actually take myself a couple of times to read it and really understand what the problem statement is. If you remember last time we took ChatGPT to run on USACO problems, it actually can get to the answer. You know, not to be biased, discriminate against anybody, but the USACO problem is written by people, native English-speaking people, right? So the language is easier to understand. The IOI problem, all the premise, everything is correct, but it's the way the problem is written is just a little bit harder to understand. So it's actually for ChatGPT 4 LLM, it's actually harder for them to understand. So you see, they did not grasp the problem that they're trying to solve is the count of the minimum frequent uh, type of insects until like now. And then they are, struggling actually write a code to solve that problem because I'm sure in the training set, most of the problem they see is to find the maximum type. Probably there's very few cases to find the minimum, least frequent type. So it's they're just struggling with this. They're trying to there's like many different versions of code they're trying to write themselves now. So they're getting more and more complicated and struggling on this. So still trying to create that. Um, to not to disappoint you, I have run this before. I just tell you the answer. The ChatGPT is not able to solve it. It will keep trying until I run out of my tokens. But the problem is just too difficult for them to solve. Again, as I said, this is as much to do with the algorithm, the difficulty of the algorithm, as well as to do the way the problem was written. So let's see where they have been. They try to define this noun type, move out with noun type. Try to create a default dictionary. They don't know how to deal with this dictionary thing, right? They don't know the type. We dealt with it without actually knowing the dictionary. They just keep struggling. And right now it's trying to use a lambda function. This has nothing to do with algorithm itself. It's trying to the coding itself. So now they give up. Okay, so we're going to do a new approach. Oh, there's a sliding window. This is not going to work. Right. Count each insect type. So it still did not realize we don't know the insect type. So have you run your code against the example and so correct answer is supposed to be 1. Which is this one, right? Okay. So let's give them. Do we have another example? Don't have another example. Let's give them another example. Here's this example. This is 5, 8, the 4 minus 21. You can see how I was struggling, and so so I think you probably already see enough. So I was not able to go against, was not able to, to basically get the result, correct result, even after all those prompts, right? It wasn't able to grasp a little bit more complicated problems. So yeah, I mean, maybe it's a good news for us as a competitive programmer that we are actually smarter than what they are doing. So let's do then another one. Let me do a So, and obviously you cannot solve and cannot get the complexity correct either, right? So, I mean, you can go back and analyze. This is the last version of the code. So, I mean, if you look at it, obviously, you know, this is not going to work. I think a new approach. Okay. So it says, I'm wrong. I will think of a new approach. Okay. So I'll say we develop for the new approach. Now it's going to go dynamic programming. Okay. So I'll stop that. Let's regen. We know dynamic programming is not going to work. Okay, now you're getting somewhere, right? We will check if there is a type of insect with a cardinality of at least mid. That will be done by moving mid into a machine button and get of the most frequent. If the return is equal that exists, let's list them. Okay, this is getting somewhere. Not exactly. Because it's still trying to, in this algorithm, you know, if the cardinality is as, that means could be the maximum, right? Where they're doing it, let me give them some more examples. Okay. So what was I just use this one. Use this example. What answer should be one. But then I can keep pumping them with more examples. But I mean, you already see enough that it just doesn't give you the correct result. Okay. Okay, so I guess you already saw enough. So basically, the conclusion is with ChatGPT, you're not able to solve the IOI problems, even though this is not one of the, I would say it's one of the easiest problem, right, in IOI 2022. So I hope you had fun today. So have a good summer, and we will see you in the next season.